Okay, so the topic of today's Byte-sized RSE session is continuous integration. This is a self-contained session, but if you attended previous sessions on linting or on unit testing, this would be a nice follow-up to those sessions because it will show you how you can scale up those other activities such as linting and testing so that they are run more in an automated fashion and that they are run, for example, every time you do a change to your code base. So what this session is going to look like, typically we do a short introduction, about 15 minutes, in which we will cover, for this session, we will cover what is automation in software development, why it's beneficial, and specifically continuous integration as an example of automation in software development, how it can help our software development process. And then we will have a practical activity. Today it will be run by Aman, where we are going to practice using continuous integration using GitHub Actions. You should have done setup for this session. Unfortunately, due to the limited time, we won't have time to troubleshoot people's setup issues or installation issues. But if you do have an issue, please put it in the chat. We might be able to help you on the fly. We also have a shared notes document where I'm just going to quickly switch to it, where we are going to ask you to sign in a little bit further down this document so that we can keep an eye on numbers. If you've seen one of these documents before, you might recall that we've got important information at the top and useful links. This document is for everyone to use. If you want to write your notes, we might be passing some links or some code in this document to you. You can bookmark it. You can come back to it again if you want to revisit your notes or some of the links or notes that we leave here for you. Right, okay, so let's get going with introduction to continuous integration. Well, firstly, let's talk a little bit about automation in software development and why do we need it. So software development is an incremental process and it's quite time consuming. So you rarely go from a blank page to a fully fledged and implemented system or application in one go. So it involves multiple steps. It often involves multiple developers, sometimes across multiple teams as well, and especially in larger projects. There is loads of moving parts and moving pieces that are being worked on in parallel. So you often need to integrate these different additions or updates and changes to the code over time. And sometimes you need to compile the code as well for some programming languages. You might want to run some tools on your software, such as linters and tests that we've covered in the past sessions, other tools that you might want to run to, for example, deploy code or something. And you need to do these things in an automated fashion, just because sometimes your software project is too large to run these things manually. So task automation is the process of using different scripts or tools to help us perform these tasks without certain tasks over our code without manual intervention. So like I said, it can help us streamline repetitive or complex tasks like running tests or building software or processing data. And it can help save us time, reduce the chance of human error because we don't run these things manually. And there is a less chance of typing some parameter wrong or some script wrong. And then it can also ensure that all of these processes are reproducible and consistent because they are documented as scripts that can be rerun. And also these scripts provide a documented way to understand how things are set up and run, and then it also makes it easier to understand or replicate or to change and build upon. So continuous integration is one example of automation practice where we are running tasks automatically each time something changes in our code base, and these are typically run in shared code repositories. We can configure continuous integration in our shared shared code repository to run daily or weekly. And we can also set it up to run every time some changes are merged, for example, from a development or a feature branch into the main branch, or even after each commit. There are quite a large number of tools and services that provide continuous integration. We will be using GitHub Actions, but GitLab also has its own CI service. It's called GitLab CI. You might have heard of Jenkins or Travis. You might have used these services in the past. So what common tasks do we normally ask continuous integration services to run for us? Well, I've already mentioned things like compiling the code, if that's what our code needs, running a test suite across multiple platform or operating systems to catch issues, checking for test coverage to see if some tests are missing, verifying that the code adheres to the guidelines that we set up for our project or as a team. We can also have tasks that build documentation pages from the doc strings, which are structured string which are embedded in our code, or other source pages. For example, every time we make a change to our code, we want the documentation to be refreshed. Or, for example, when we want to release the code, we can then run these scripts to build documentation. And then other custom tasks, which might depend on your project or on your team. So what are the benefits of continuous integration or automation as a whole? Well, clearly it will save time and effort by automating these routine checks and tasks, allowing the development team to focus on code development rather than running these tools manually. It enables us to run a large number of tasks and checks across multiple platforms and operating systems or software versions, and basically providing capabilities for us far beyond we can typically do manually on a local infrastructure. And it also promotes good development practices by enforcing standards. So, for example, you might have your continuous integration configured, and many projects do actually use this practice to reject any change unless certain checks pass. So, for example, your pull request or your request to merge your changes into the main development branch will be rejected if your contribution has spelling checks, if it's got links that don't work, if it doesn't conform to certain style guidelines and so on. So you can set these things up for your team and your project as you wish. So just to highlight, there is a bit of a learning curve when you are first met with setting up continuous integration. There's a couple of things to learn. There is also a wide variety of tools available. So even though you might have to learn a little bit more at the beginning, the core principles of continuous integration are transferable between different CI tools. So they all work in a similar way. So once you master these skills, they become valuable and broadly applicable and transferable to other CI platforms or tools that you might use in the future. Okay, so we are going to switch to the practical activity now. I'm going to stop sharing and hand over to Aman to take us through using GitHub Actions for continuous integration.
Thanks a lot, Alex. Yes, let me just share the slides. I'll make an introduction and then we'll get into the practical. Okay, hello, welcome folks. Thanks for joining us and thanks for the introduction, Alex. Today we'll be looking at continuous integration. We'll look at some workflows. If you attended the previous sessions, you might be familiar with some of the code we'll look at today. We'll look at the same code that we looked at for unit testing yesterday. So we'll look at the factorial example. Now, what we'll do today is we'll set up a CI workflow, so a continuous integration workflow, and we'll run unit tests when changes are made to the repository. So that's, again, we'll do it similarly to what we did yesterday. Then we'll use GitHub Actions, and but these are again general skills that can be transferred to most sort of continuous integration platforms and workflow platforms, and a lot of workflows use similar sort of patterns and languages in executing the tasks that we'll define today. And then we'll demonstrate this via live coding. We'll use a template, GitHub repository, and we'll get it on our account. We'll clone it, and then we'll directly edit some stuff on GitHub to see how the workflows and the actions work. Now, yeah, as I said, we'll start with cloning the repository, and we have some unit tests that we also looked at yesterday. We'll look at the YAML, which I'll briefly talk about. So YAML is the format that we'll use for defining our workflows. Like so far, we've been doing, say, if we've been writing code in Python, we use the .py. This will be .yml. And then we'll add the GitHub Actions workflow and then run them. And if time allows us, we can look at using build matrices, which are basically ways, which is a helpful tool so that helps you run different tests, the workflow on different platforms and using different language versions. And you can do a lot of things with simple commands. So if we get the time, we'll go there as well. Now, just as a quick check, like we did yesterday as well, if you have done the setup as well as want to follow along in the practical, could you give us a green tick so that we just have an idea of numbers? So if you want to follow along, but your setup is not ready, you can also type it in the chat or give us a red cross. Either or works, and you don't have to commit right now. You can, again, feel free to follow along as we go and decide for yourself. Okay, so we've got few responses. That's great. So what we'll do is we'll again use similar tools to yesterday. So just to check, as the pre-setup requirements, we have our software repository. So that's the GitHub version. So you should be logged into your GitHub. Then you should have set up Python and access to a terminal, a bash terminal on your machine, whichever OS you're on. And then we'll use VS Code to do some code editing and also create virtual environments. But that again, we'll do that as long as your Python installed, it should work. Now I'll quickly share my screen again and we can get started with the activity. Let me just figure out all my tabs and screens for a second. Just a brief minute. Okay. Is my screen visible now? You should be able to see the material that we'll be using today. Perfect. I see a thumbs up from Steve. Thank you. So again, just a reminder, we won't be able to debug a lot as we go. You can type the questions you have or any sort of issues you run into in the chat or in the document. I'll try to address them as we go if they're possible to sort of deal with in a minute or so, but we can't do like detailed debugging today because it's the time limits. So what we'll first do is we'll go to our example repository. So we have this CI example. I'll paste the link in the chat. So this is our template repository. Did that message send? I think my Zoom might be lagging. Just a minute. Apologies, my Zoom has stopped responding. Let me figure this out. Can everyone hear me?
Yeah, we can hear you.
Okay, my Zoom interface is lagging. Like my internet seems fine, but the interface is not responding. Give me
You froze for a second, your video.
right. Yeah, so I'm not sure what's happening. Uh, let me see. So please do just flag if I freeze up or if something stops responding. I think Zoom is being a little fidgety, but hopefully it won't be an issue. Let's try again. Mm, Okay, I'll try the sharing again. Okay, we're back to the sharing. Hopefully it won't be as laggy as before. Let's see. So yeah, we are looking at this example repository. Now, pasted this in the chat. Now, what we'll do today is we'll first create, so this is a template repository. We'll create a copy of this template into our own accounts, and then we'll get it onto our local machines. So let's go to this repository and I'll click on use this template. So the green button on the top, and I'll click on create a new repository. So once I do that, I see the screen, which gives me the the option to create a new repository, and it gives me a few options to configure. What we'll do here is just simply keep the name similar. So we can just say CI example, and then we can choose an owner. So you in this dropdown, you would want it to be your own account or whichever account you're using today on GitHub to configure and follow along. And once you're able to do that, we don't need to change anything else. You can just click on create repository. So this will take a few seconds. Now, just to reload that. Okay. So just to recap, we have this repository in universe HPC called CI example. We go to the use this template button. We create a new repository. Then we type the repository name. It won't allow me to create the same one because I have one under my account. But you create CI example from here and you click on create repository. And that should take you to the template repository that you have. So this is mine, which is existing under my account, my own account now, instead of just on GitHub. Now, if you're able to do that, we'll now clone it onto our local machine. So now in the new repository, this is under your own username that you've created from the template. We'll go to the home page of this and we'll click on the code button and we'll clone it using this URL. So I'll copy this URL, the HTTPS URL, then I will use a terminal to get this onto my machine. So let's see. First, so I have this terminal. Hopefully that's big enough. Let me know if the text is not visible clearly. What we'll do is we'll go into a folder that we would like to use for this session. So this is my folder, RSE 25. You can clone it anywhere you like, anywhere you feel comfortable. Now, if I do an ls, it shows what already exists in this folder for me. You might have other things, you might not have other things. But now what I'll do is I'll do a git clone, and then I'll paste this example. So when I do git clone and I paste this, I'll paste the command as well. You should replace the username with your own username. And you should be able to clone this. And once I do the ls, it shows that it is running again. So let me just check. Yeah, so we have created our own repository from the template, and then we have cloned the new repository from our personal account. to the local machine. If you're able to do that, if you're able to follow that so far, could you give us a green tick, please? Okay, I see a lot of green ticks. That's great. So now what we can do is we can open up VS Code. So preferably VS Code or any editor you like, and I will open this factorial example in VS Code. So this is VS Code. I've opened this folder here, and let me see. Oh, I think I opened the wrong one. Just a second. That's the unit test from yesterday. Either or should work, but we want to open the new repository. Also keep in mind that, yeah, if you are using VS Code and if you have folders or if you have the new repository that you cloned in the same location, just be careful you don't open the old one because it might have similar folders and you want the new one that you cloned just today. So I'll go back to that again. Let's see. And yeah, so it's called CI example. This is the one that we need. And we are in CI example now in Visual Studio Code. And now what I'll also do is I'll open a terminal. So to open a terminal, there should be in your status bar on your OS, a way to, there should be a heading called terminal where you can open a new terminal. On Mac, it's right on the top, but we open a terminal here. And this again is similar to the terminal that we were using before. And now from this terminal, what we'll do is we'll test our code. So if we look at these folders, we have a factorial.py. So the code we looked at yesterday, and a test factorial.py. So factorial.py is defining a factorial for us. It's giving us a function which has which calculates factorials. And then we have a test file which does the testing. And it is a little different from yesterday, but almost similar. So we don't use unit tests today like we used yesterday, but everything else is almost the same. So now let's go back to our terminal. And what I'll do is I'll type Python 3. You can type Python or Python 3, and that should activate your Python prompt, command prompt. And similar to yesterday, I will do an import of the function and I will test it. So for doing that, we execute from mymath.factorial import factorial. So once we do that, it will get the function that we need for executing the factorial function. And then we can give it a number and it should give us the output. So if I say 3, it gives me the factorial of 3, that's the output 6. So same I can do, say, for 5, it should give me 120, and we know that the code is working. So this is, again, all of this so far, some folks might have done this yesterday or might be familiar with already, but this is just a way to test our code. So this is the factorial function. Now, what we'll do is we look at the tests. Again, similar to yesterday, we have a test file where we have unit tests. So these are the tests that we added yesterday. But again, as you might observe, it's a little different. So today we are doing an import on top. We say import PyTest, and that's what we were talking about earlier. PyTest is one of the popular frameworks that is used for unit testing in just Python testing in general. And PyTest makes it simpler, makes it easier for us to test. And again, it's a lot of the times PyTest is kind of the standard. Unit test is not very common nowadays, but it's very simple and it's within Python. And yesterday we also had a class here which contained all of these methods. But today we don't have a class in PyTest. You don't need to define a testing class by default. And we can just define our methods, and those methods will be called as we test the functions. So yeah, we have the import PyTest, and we don't have a class, but the rest looks similar. So this is to explain how our new syntax looks like. Now, these tests, again, just to explain briefly, this is doing a factorial test that tests the factorial of 3. and it verifies it against a value we have given it, a known value. So we know it's 6, and the function should also return 6. And when it does that, we know that it's working correctly. We do that for 5. And then we also test for negative, where if we try executing a negative number, or we try calculating the factorial of a negative number, it should give us an error instead of just giving us an answer. So let's go back to our terminal. Let me show you. If I do a factorial of -1, oh, that was okay. So I will input that again, and then I do a factorial of -1. So yeah, that gives us an error that is expected, and that is also something that we are testing for. Now, this is PyTest. Now, what we can do again to run those tests. So yesterday we were executing the unit testing framework from the Python call. But to run PyTest, what we need to do is first install PyTest on our own environment. So this is in the code, and this is in the GitHub repository, but we don't have PyTest installed on our own system. And I briefly again mentioned yesterday, or you might have done this before in one of the previous sessions, where we set up a virtual environment. So to install PyTest, what we'll do is we'll install a new virtual environment, and that new virtual environment will help us isolate this Python, isolate this sort of instance of Python into our own version, and it won't interact with system Python. So if we install Python, it would not interfere with, say, the Python you might already have on your system. And it's generally good practice to do everything that you do in isolated environments so that it does not mess up any of the system tools or any of the system packages. So again, what we'll do here is I will type Python -m venv. So I'll explain this. So venv basically is the virtual environment. It's short for virtual environment. So the Python M is the command that we're giving. Then venv is also the command that we are telling it we want to create a new virtual environment. And the last venv, that's basically the directory we are telling it where we want to create the virtual environment. So it would be the name of the virtual environment and the directory. So say, for example, if I said xyz/venv, it will give me that venv folder in an xyz directory in my current folder. But we will keep it simple. We will just do venv. Sometimes you can also do .venv. There are lots of different sort of methodologies or lots of different ways to do this. There's no standardization, which again can be tricky sometimes to know what's best practice. So when we, okay, so I need to do Python 3 because my system does not detect Python because it does not allow us to call Python 2, which used to be the standard in Mac. So when I execute this, it will create a new environment for me and will work in the background. And once it's done, we'll see some output. Okay, so it says that it's executed. Now, if we look at our files here on the left, we see a venv folder has been created. So this is the folder that you should see. Now, if you're able to run this command, wait, let us in fact activate it as well, and then we'll do a quick check. So to activate this, what we do is we do a source. So source is calling the file that we'll use to activate the virtual environment. And what we'll do is we'll say source, and then we'll give it the directory of the virtual environment. So for Linux and Mac, this should be your output. So you do source venv and then /bin/activate. And once I do this, I see this bracket venv. I'll increase the size. I see this, which means that our Python has been activated within the virtual environment. Now, this, just to make clear, this interface might look different for you. This is a modified version of Bash for me. This bracket venv might show here for you next to the arrow or somewhere else. But this is just like a customization that I've put on top just to make it easier for myself to navigate the Bash. So if you've been able to create the venv and activate it if you could give us a green tick. I'll also paste the command for Windows, so it should be source venv scripts activate. So that's the Windows command. And for Linux and Mac, it's source venv bin activate for Linux and Mac. So, okay, I see a few green ticks, red cross. Okay, so if folks are facing issues, would you like to type in the chat, or is it just a case of that you would like to go over the steps again? But basically what we did was we went to our VS Code and went to the same directory where we opened the directory where we cloned our repository. So from your own username. So if I do a pwd, it shows me which directory I'm in. Print working directory will give me the CI example directory. This is where I want to be. And then what we did was to basically run PyTest. What we are doing is we are creating a Python environment. So for that, the command is this Python -n -v. And on Mac, you might need to use Python 3 instead of Python -m. Okay, so there's an error. The term source is not recognized as the name of a command-led function. Ooh, okay, so this is a Windows error. Any insights on this? This might be the same issue as we faced it for something else before, where we had to correct the paths and then do the installation. But
I wonder if this is run in Git bash. If it's not run in Git bash, maybe it's run in some other command line terminal in Windows. Maybe.
Yeah, just to cross check as well for Theodora, if you are which terminal you're using, you're in the VS Code. Okay, but do you have the Git terminal? And yeah, so Git bash should be able to use that. Again, if you do not know, so again, you should be able to switch your terminal from here, where it gives me the option for bash and ZSH. On Windows as well, I would imagine it would show you the options. So instead of PowerShell, you need to select Git bash. If you don't see it, you can open your Git bash separately and do the same thing. It should be the same. It does not make a difference if we do it from within VS Code or outside. As long as you're in the same directory, it should work. And just to also clarify for Anna, so the error you're getting, if you're on Mac and you try to execute Python 3 instead, that might help. But if you're still facing an error, let us know. You're on Windows. Okay. And again, just make sure, I guess, you are on Git bash. If you don't see an option to switch to Git bash from VS Code, you can use your regular terminal. I can show you. So this is basically my regular terminal. And this is, so if I go into my CI example, now, okay. So if I go into my CI example and a print work do a pwd command, we'll be in the same repository of same location in both these terminals. So they are at the same place. And here as well, I can execute the same command and should run. But for Windows, it might be different, where one is git bash, one is not. In the interest of time, I will leave that debugging to Steve and Alex to look at that in the chat. But if you've been able to follow this through, again, apologies, because I do not also directly know what the Windows sort of debugging might look like, because I'm currently on a Mac system, or I would have just tested it myself. But once you're in the VN and you've activated it, if you do a which Python, you should be able to see where you are or which Python you're using. So for me, it shows that this is the Python within the V and bin and then Python. That means that we're using the local Python instead of the system Python. So if you do this, you should be able to see your local Python. If you see a different Python, which is not according to your new virtual environment, then that might be an issue as well. So if you're able to see your local Python, and you can give us a green tick. Okay, I see a few green ticks coming in. That's great. And now what we'll do is we'll install PyTest into our environment. So we've created this environment, and right now it does not have any packages installed. So what we'll do is we'll do a pip3 slash, we can do pip3 or pip. So it's similar to like we were calling Python. So pip install PyTest or pip3 install PyTest, probably better for Mac users, but it shouldn't make a difference inside the venv. And when we execute that, it will install the PyTest package from either the internet, or if it's locally safe for your system. Sometimes VS Code gives us a warning when we do this, and that warning can be safely ignored, because when we do a pip install PyTest and it's within a venv, VS Code sometimes thinks that we are making a system installation, which we are not, because we've verified that. And again, you would want to avoid a system installation, but currently, again, we are installing this into our own local virtual environment. So once you've done that, again, the command is pip install PyTest. You should have PyTest running for your system. So if I click on PyTest, it gives me some output. Otherwise, it would tell me command not found or some other error. But when it's doing this, that means that PyTest is running. Now we need to run it with the proper syntax, where we'll do Python -m. And yesterday we were using unit test. Instead of that, we use PyTest. And then we say tests. And then we give it the test factorial.py file. So this is the command that we are using. I will just make it Python 3 for consistency. And if I run this command, this should run my PyTest tests. This file should be running, and it will give us the output of those tests. So I run this, and again, similar to the unit test, it gives us this output which says 3 parsed in 0.03 seconds, and it gives me these 3 dots. So just to again explain what this means, it's slightly different to what we saw yesterday, but overall it's similar in the in terms of, okay, it's checked the number of tests and it gives us the output on how it's working. So a dot means that the test has been passed, and if we saw a capital F, that would mean a test has failed. So that's how PyTest gives us the output. So just to show you that, if I make this 120 into 12, that means my second test should fail. And if I run this again, we'll be able to see that. So yeah, now you see a dot F and then dot again. That means the second test has failed here. The F is for fail, and then it gives the details where it's failing or what's it's expecting, where again it's saying that we are trying to equate 120 equal to 12, which is false. That's why it gives us an F. So I'll fix that and I'll clear that. So this is a command that we used to run the test. If you've been able to successfully install PyTest and then run the tests through PyTest, could you give us a green tick again? Amazing. I see lots of green ticks. So then, after having cross-checked our setup, we can finally get onto the workflow aspect of things. So that was basically our setup. This is the file we're using for the workflows. Now, we can also execute these tests using a -v, which is basically the flag for using verbose. So if I go back to this command, Python 3 -m PyTest, and then I add a -v here, that means verbose. Now the output that we'll get will have more information about what's happening in the background, or what tests exactly are being executed. So when we do this, it shows us the name of the test and it's passed, and it gave us the stage of the testing. So this is very helpful when you're running a lot of tests, or when you need to see some more information on what PyTest is doing. That's one a sort of simple way to look at what is going on behind the scenes in a command. So that's about PyTest, and I think most folks have been able to run successfully. So now we can move to the workflow part of the session. So just to again make sure. So once we've done that, we'll return to our GitHub, and this is where we'll be making our changes. So I'll clear the feedback, give folks a second, and if everyone could return to their GitHub repositories, you should be able to, you should be able to see the repository as it is. We haven't pushed anything back. We haven't made any changes yet to the code itself. We've just added our virtual environment. And we have run PyTest to verify that our code is running successfully. Now, the advantage of this is once we have run our code and once we've run our tests, we know that by default that our tests are running successfully and they can be automated. So once your code is all good to be run, you've verified it's running correctly, everything is working fine, the automation makes more sense. The automation becomes easier where you've checked the robustness and then you can tell the tell the GitHub Actions, tell the sort of continuous integration that, okay, this is what we want to automate and this is how we want to automate it. Now, what, again, a quick explanation I'll do for YAML as well before we get into the automation itself. So let me see. I'll just use this as a scratch space. So just a quick overview of YAML is example.yml. So YAML is a markup language. It has kind of a couple of funny acronyms. One of it is yet another markup language. And then I think they changed it to YAML ain't markup language, which is just, it's somewhat of a markup language, but it's not really a markup language. But it's used a lot in like a lot of workflows and a lot of controlling variables and a lot of configurations. You might have come across this system or the sort of similar syntax in a few different files. So another one you might have heard of would be TOML, which is TOML instead of YAML. Now, how it works is it is based on key value pairs. So here, we've just taken an example where we say name, and then we give it the value of the name. Then we give the height, and we give the value of the height, and then we say it was first scaled by this person, and then we give the name of the person. So these are the fields, the key value pairs. We can also define it using more complex data structures. So another example of this would be doing it like this. So this would be a YAML array where we say first scale by, and then we add two names. So that has two values. And there's also a short form to represent the same information, which would be something like this, where it's first scale by, and then we use two square brackets, and then we give it all the values. So if we give it a third value, and we give it a third value here, those are essentially the same syntaxes. That's basically just telling YAML, telling the syntax that this is an array and these are the values that we have here. And then you can, again, combine sort of these structures. You can mix and match. You can have nested structures. So example of that would be, say, having something like this, where you have name, then you have height. And in the height, you have a value, you have the unit, then you have when it was measured, then you go another layer. So you can have like a lot of metadata. YAML is very good for having deep nested information or a lot of information in concise, readable formats. And then if we just combine the maps and the arrays, I'll just show another quick example. So this is what we've done where we've said first scale by, that's our overall heading that is mapping this information. And then so first scale by will be the array. And then we have this map showing all the details in that array. So it's kind of similar to if we had first scaled by here, and then so if we had this information somewhat like this, so all this information can also go within the brackets, but this is easier because we're increasing the information here. So that's a quick run through of YAML and understanding on what language we look at the workflow when we are running our workflow today. Now, if you've been, I'll just do a quick check again. If folks have sort of a decent idea of how YAML works or what this sort of language looks like, if you could give us a green tick or red crosses or any questions in the chat. And then, because this will be very helpful when we write the workflows, and this is a similar format we'll use, and we won't have to sort of look at the syntax in the sense of from the perspective of YAML, and we can focus on how the YAML is working itself. Okay, so I see a few green ticks. So is it close to XML? XML is similar, so it uses tags to define the elements, and it's in a tree structure. But basically, there are a few markup languages that are very popular for defining metadata or configurations. So you might have come across XML or YAML or JSON or TOML, and these are all popular file formats used for different things. For workflows, YAML is very popular. For GitHub Actions, for GitHub workflows especially, YAML, I think, is the usual default standard. But I think you can write workflows in other languages as well if you wish. You just have to make sure your configuration is set up for that. Not every time it would work on every platform. Some platforms or some sort of tools have a preference for one versus the other. So now what we'll do is, if we have if we've got a good idea of YAML, we look at our settings to enable the actions. So, oh, my bad, ignore that. My Zoom is being fiddly. Yeah. So what we'll do is we'll go to our settings. So you go to your example repository again. So this should look like something like this, with instead of the username that I have put, it should be your username, and it's basically the repository we just used to make the new repository from the template. Now we go to the home page, the settings. So that's the last option here towards the right on top. So the tab under settings. Then we go to actions. So under general on the left, we go to actions, which is under the second heading under code and automation. So this is what we're looking at. I'll zoom in now. So actions is what we're looking at. And then we go to general. And once we've clicked on general, the information on the right changes. It shows us what information it has under this option. And we just need to make sure that this option is enabled. So allow all actions and reusable workflows. And it should be enabled, it should be selected, and we just click on save. So by default, it should be enabled on your repository, and you should not need to make a change. But this is also just to quickly point that sometimes repositories have either the actions disabled or some settings changed, or if you're working, say, in a collaboration, it might not look similar. They might have different settings, and that might give you an error with GitHub Actions. So we have checked that our actions are enabled. So once we've done that, we go back to the code tab again. And once we're on the code tab, what we'll do is we'll click on the plus button here. So that is to create a new file. Now, most of the work we'll do on the workflows will be from within GitHub, and it's easier to just navigate from within GitHub. So I'll click on the plus here, and once I click on plus, I should be able to see this option, and I'll click on create new file. So and just do a quick check. If everyone has been able to follow so far and they are seeing this interface with sort of the option to create a new file, if you could give us a green tick. Okay, I see the green ticks coming in. Now, what we will do is that we will name this file first. So a quick note that GitHub, when it looks for workflows, uses a standard directory called .github/workflows. So this is the directory we want to create a new file in. So because we are currently not in the directory that we need to be, we can just add our name according to that directory, and it should just put it in the right place for us. So what we'll do is we will, in the name your file section, we'll type .github, and then we'll do a slash. And as soon as you see do a slash // you'll see that this .github goes in the directory structure, and then you can name your file. Now we need to go another layer here. So we do workflows, and then I'll put another slash. Wait, yeah, we'll do another slash here. And once I do another slash, this will bring us to the final name of the file. And just a second. So, and once I do this, I will type main.yml. And as soon as I do this, I'll see the automated GitHub workflow. It will show us a few options. That means that this is the correct file name. This is the correct location we want to be in, because again, GitHub has intelligent features which detects that we are creating a workflow and gives us some default options for using workflows. This might show up for you by default if you've not changed your GitHub settings. It might not. Sometimes it depends on version. Sometimes it depends on what location you're in. And just to do a quick recap of what we did is basically first we looked at the settings, which was the last tab. We went to the actions and we made sure this is enabled. Now, after we did that, we will go to the code, the first page, the main page again. So this is just the general URL for your own repository. Then I clicked on plus, which is to create a new file, and I clicked on creating a new file. Then we do the naming, which is .github/workflows/main.yml. I'll just also paste the link to the material that we can look at for this, which might be helpful for you to understand where we are in the material if you want to follow through. So this is the general link to the material. It's also in the notes, I think. And if you've been able to look at that, we are on the defining a workflow episode. And let me just quickly pull that up. So this is how far we've gotten so far. So our final path will look something like this. So CI example, then .github, then workflows. So /.github/workflows /main.yml. Main.yml is the name of our file itself, and this is the path that we want. Now, let's build the workflows. So if everyone has been able to get their file naming main.yml, you might see this tab, this information that I see on the right with the marketplace and the documentation. Could you give us a green tick? Even if you don't see the marketplace or the documentation, but you feel you're in fact, if you don't see the marketplace and documentation, give me a red cross, because I think by default it should show up for everyone. But yeah, this is the path we're looking at. And this again, like now, gives us the example. So if you look at the documentation, this is the YAML syntax we were looking at earlier, and we'll type something similar. We'll create a workflow using something similar. So I see one red cross, and if you could just type in the chat what your issue is, we can look at that. You might be in the correct repository, but might not be able to see the marketplace, this automatic information, which does not show up every time. But please do tell us if you're facing an issue, or if you want a recap on anything, or if there's a confusion. Okay, if you don't see the marketplace, that might be a different issue then. I was just assuming that because again, by default, it shows up. Sometimes there are different reasons why it doesn't. But as long as you can make sure you are in this .github/workflows directory, it shouldn't be an issue. And we can verify that soon. So we'll create the workflow. And even then, if your workflow doesn't run, then we'll then there might be something to figure out why, say, the workflow is not working because it's the wrong directory or something is not enabled. Uh, but yeah, that's not the biggest issue. And there is, yeah, I think someone mentioned there's the collapse help panel here. So maybe my help panel was expanded. That's why I see it. So now we'll write our workflow. So we say name, and then we say run unit tests, and then we say on push. So the name is defining the name of our workflow, and then the on is giving it the command that the hook that it will run on. So we say whenever we push, we want to run this workflow. So the push is again, when we use the Git terminology, we use push whenever we push our code or push our files or anything to the repository. So whenever we make a push or whenever we make a change, this workflow will automatically execute. Now, what we'll also do is we'll add the jobs and then we'll add the steps. So how workflows run, basically, we have a sequence of jobs. So we can build our code, we can run our tests, we can do something else. So it's kind of like what we were doing in the Python interface when we were saying run PyTest like this, run this code like this. That's something that we can do similarly on a workflow, which will automate it for us. And we can also do, say, we did the install PyTest. So first you'll install it, then you'll run it, then you'll check the output. And say if it runs into an error, it will throw us an error. And that's helpful to know that, oh, this is what's going wrong. So what we'll do is we'll define our jobs. So we give it the title jobs, and then we use two spaces. So similar to Python, YAML works using indentation. So the indentation sort of gives us the layers of the file. And what we'll do is we'll give two spaces here, and then we'll say build and test. So this is again just the name that we are giving manually. This can be different. It can be build, it can be test, it can be different steps, however we define it. These are the actions that we want. So we are telling the workflow we want to build and test, and then test is a keyword. So we say runs on, and then we say Ubuntu latest. So this is our operating system. So Ubuntu is the Linux operating system that we'll test on, and we say we want to test on the Ubuntu latest operating system. We don't have to worry about it. GitHub will take care of that for us. So how workflows sort of run again is they use something called a runner, and you can think of that as kind of a fresh instance of like an operating system. So kind of like a virtual machine, or just like say your own system. And when we say, okay, we are on Mac or Linux or Windows, and we are installing these things and we are running this script, something similar will happen within this action, within this workflow, but on a much faster, on a much quicker and more efficient scale, where what we are essentially doing is this job that we have defined will look at what the commands are, and it will execute them within a runner, which is the instance of that job. So a runner would be, in this case, let's say the Ubuntu latest. Now, if we said Ubuntu latest and Mac OS, we would have two runners, one for Ubuntu, one for Mac OS, where that workflow would be executed. So this is how the syntax for the workflow sort of is defined. Basically, you can look at the documentation as well. Now, once we have done this, I'll also just paste this in the chat. I'll paste it in the shared notes, in fact, because the syntax might be a little tricky with the spaces. So I've pasted this on the last page, and this is our code. But basically, it's like the indentation is two spaces each time, and here as well. So we have the same indentation for name, on, and jobs. And then for build and test, it's one level intended inside. And then runs on is another level. So this is the third level of indentation. We have the whole script available on the top if you want to look at it, but I think it's better to go step by step so that we can just look at what's going on in our script and you have experience of how you write the script itself. So so this is our workflow file again. Now, if we go back to the workflow file, we can look at how we want to sort of run this. Now, once we've done the runs on, we'll define the steps that we want to give this workflow. So there's a question. Yes, we'll get to that in a bit, and I'll highlight that if we might not be able to follow it through on how to run that through a matrix, but that is the last episode of this lesson. If you look in the material on how you run things on different operating systems concurrently using different, say, even Python languages if you want. Now, what I'll do is I'll paste this code that we have in the material. So I've defined the steps for this runner where we say, first, we want to check out the repository. So check out, so this name again is not default. I can say anything. So if I say checkout branch, it will accept it, but that would not be the right sort of variable name. So it's kind of like when you do variable naming, you want to do it correctly so that it tells you what action is being run out. And then we say setup Python. So for both of those, we use this keyword called actions. So actions is the GitHub actions keyword, which will execute GitHub actions, and then it will execute this command. So we check out our repository, and then we say setup Python. Setup Python is again, it will do the Python setup on its own on the runner, on the Ubuntu that we are telling it to run on. And then we give it the Python version. So we tell it that we want to install Python version 3.11. Now, once we've done that, okay, let's do a quick check because we have just created this workflow and we have entered all the information to set up our Python on this workflow. So if folks have been able to follow so far and you're able to understand the syntax, type it out, run it, not run it yet, just sort of follow the steps so far, could you give us a green tick? If you have any issues, if something feels unclear or you don't understand, you can give us a red cross or type it in the chat. I'll paste the new code. So this is where we want to be, where we have defined the name, the jobs, and set up Python. Okay, I see a few green ticks. I'll wait a couple more seconds for people. Just to look at the chat. Okay, thanks, Alex, for answering that. So yeah, those are the versions. For the hyphen versus spaces, I think it's just the syntax on how you define it. I do not have the correct like the actual answer, but I think it's just like if we see here, whenever we are say defining things, yeah, I think it's like when you define your final sort of variable, final information. So again, build and test is generalized, runs on is generalized, steps is also generalized, but then we say a name, that's the particular information we have. But again, I'm not sure why the hyphen particularly instead of just the indentation. So I'm not sure if we could just do this.
It's a list notation in YAML syntax.
Yeah. Okay, yeah. So the YAML syntax basically.
In our file, steps is a series of steps, and each, well, we have two steps defined. The checkout repository, the second set up Python, and that's just how YAML defines lists. In this case, our steps variable is a list with two elements.
That makes sense. So yeah, whenever we give it the hyphen, it tells us that this is a step. So that's why it is kind of differentiating. So yeah, it's kind of similar to, yeah, in fact, that's what we looked at earlier when we had, say, the array and we gave it the different values with the hyphens. It's similar. I think what just made it a little different to look at is because it's a little more nested and it has a few layers. But if we do this, that makes it two different steps, which we don't want. This is all a part of one step. So we just define the hyphen and then we sort of tell the step, tell what the step is. Now, what we will quickly do is, I see the text coming in. Perfect. So if you've been able to follow so far, now we'll install the Python dependencies. So like we installed the PyTest and we made the virtual environment, we will tell it to install PyTest as well. And we will then sort of execute the workflow and it should run the PyTest for us like we did manually on VS Code. So let me just quickly get that material. So again, what we'll do here is we'll say name, install Python dependencies, and then we'll give these commands to our workflow. I'll paste this here. Okay, so if folks can basically format that, but just make sure that it's on the third level of indentation. I would not waste time on that right now. But again, there is the script available on the top that Steve made available for us very kindly. So this is essentially the workflow we're looking at. You can just copy this directly. It explains what's going on. But for the purpose of doing it step by step, so we install the Python dependencies where we tell it to first do the pip installation and then use requirements.txt. And requirements.txt in this case will take care of the installation of all the packages we need. So PyTest, like we install manually. And then we say test with PyTest, and we say we execute the same command that we did on our own system. So this is the workflow. This is the overall workflow that should look like in the first instance. And if you're able to get here so far, if you have your workflow all set up to be run, all set up until this last stage, testing with PyTest. Can you give a screen tick, please? Okay, I see the green ticks coming in. Okay, so if we have this set up, now what we can do is we can basically commit these changes in GitHub directly, and we can see how it will run. So what we'll do here is we will go to the top and we'll click on commit changes on top on the right. And once we click that, it should give us this. Oh, that's, I think, automatic. The intelligent sort of autocomplete for GitHub. But what we'll do here is we will just sort of click on commit. It gives us this window and we'll say initial workflow to run tests on push. You can use any sort of commit message here, but as long as you understand it. Now, quickly, just to recap, so we say we first define the name, then we said when we push, we want to run this workflow. So every time we push, this workflow will run automatically. And then we look at the jobs and we say build and test. We define the OS we want to run on, and then we give it the steps. So we first check out the repository, set up our Python, install the dependencies, and then do the testing with PyTest. Now we've tested that our PyTest, sort of the tests that we have defined, they're all correct. This is what we want to automate. This is what we want to run. And what we'll do is we will then commit this. And as soon as we commit this, we should see some output on how it's run. So I will make the commit, add the commit message here, and then commit directly to the main, and I'll click on commit changes. So I've done this. Now, if I go to code and if I look at my code history, I see this yellow dot. So it is not there in the initial commit, but this yellow dot means that there is some live dynamic action going on. And if I click on that, we see that the workflow is running. So this is just a quick sort of indicator. But basically, if you go to your actions tab, so I was in the code tab, I go to my actions tab and I see this. Okay, it gets us a green tick now. That shows us that the initial workflow has run. Now, if we quickly look at the workflow itself, we see that this workflow is within the Actions tab. I clicked on it and I see the build and test workflow. So I click on the jobs. And once you click on jobs, you'll be able to see all the different sort of steps that you defined. So it sets up the job, but then these are the steps we defined, and then it does the post after the cleanup. And if I expand the test with PyTest, we will see a similar output of what we saw on our own system. So this is all being run on GitHub on an Ubuntu system by its own. So we did not need to set this up manually. We just sort of defined it. But now every time we make a push, every time we make a change, it will just give us, it will run this action again. So if folks have been able to successfully look at this actions tab, look at their, make sure that they have a green tick, their workflow ran. Could you give us a green tick? If your workflow didn't run, has an error, or you cannot see this, you can give us a red cross. Okay, we have one red cross. If you could quickly type in the chat what issue you were facing. I'll just demonstrate how basically we can trigger that by making any changes to our code. So for example, we go to my math and we go to factorial.py. So this is essentially this factorial file that we had. And what we'll do here is let's just insert an empty line before the last line. So you can insert an empty line anywhere, but essentially what that does is it changes the code for us. And there is a line that GitHub realizes. So Git realizes that has changed. So I just add an empty line. You can add a comment, you can add anything that basically does not change the code itself. And then I say update factorial.py. And when I click this, I can go back to my actions again. And in a second, it should show me. Yeah, so on this commit, I see the name of the commit. I see a yellow dot. In fact, here, yeah, it's doing it live. We can see it running live for us. For big workflows, it's much more easier to see that. For quick workflows, sometimes it just automatically goes to a green tick. I can see a red cross from before. I'll clear the feedback quickly and just do a quick check if everyone has been able to follow so far. And if we've been able to do that, that would basically, yep, I see the green ticks again. So we have these actions. You can run these on sort of different examples. Now, just before we wrap up, I'll show you a quick example of how we do the multiple runs. So in this repository, what we did was we have the workflows, and this is a matrix. And this is where we define that we want to run this workflow on Ubuntu, on Mac OS, and on Windows. And we want to use these 3 Python versions. And once we have defined this, we replace the runs on and we replace the Python version here, and it plugs in those values. So what this basically does is it takes all these 3 values and matches it with these 3 values like a matrix. So it would be a 3x3 matrix, 9 total workflows, 9 versions of it with every combination. And if I look at my examples, I will see that there are 9 different jobs, and these jobs are executed consecutively. And So first it did on Ubuntu 3 and then used Python 3.10. Then it did Ubuntu and then Python 3.11. Same for Mac with different Pythons, different OS, and it ran all of them together. So that's one example. The details for this, because we do not have time to cover it today, I'll paste the link of the lesson to the chat. And if you look at this, if you look at the last sort of episode in the material, this explains it in detail on what's going on how we define the matrix. But it's basically giving it all those values like we did in an array, and then you basically tell whatever you need to say have multiple values for. So if you have multiple values for your matrix, for your operating system, or if you have multiple values for your Python, you basically plug it there like we do for files for variables, and it will take care of that for us. Okay, so yeah, I think that's all from us for today.